Okay, welcome back. We're still in unit number 2. We're working through distance and displacement on this particular video. We just covered scalars and vectors. We said that a scalar is a measurement that contains just how big it is, and a vector is a measurement that not only how big it is, but which way is that measurement made. Up, left, round, down, north, south, east, west, anything along those lines. And we're going to take the scalar and vector, apply it to measuring distance into the first term. And the first one is distance, and so it is the total path one traversed and moving from one location to another. In class, what I do, I trundle wheel, which is just a wheel that measures distance, and I just walk around the classroom, and it clicks off, and basically it'll tell you how far you went, and that's basically distance. So for example, if I were to start a line and just weave it around, and I finished here, so there's my end. If I measure that line with the taper, that would be the displacement. See which way? This tells me how far. So maybe this might be maybe like 4 feet of motion. It would be distance. Notice there's no unit there. So the abbreviation, we actually have a number of. The one that we're going to use quite often, pretty much exclusively this year, is the letter D. So it makes it real simple. You will see the letter S being used, X, and you'll also see Y being used. So for those of you that move on to college, and college, beware that some professors, some teachers, some instructors S, X, or Y, and try to avoid the D, and that's no problem with that. Now, since it doesn't matter direction, this can be classified as a scalar. We're going to call it a scalar because the direction is not indicated. As soon as we indicate direction, we get to a new concept, and that's going to be displacement. And so here's displacement. This one is a different definition. It's a straight line distance between 2 points, including the direction. There's actually 2 things that distinguish displacement from distance. Is that its direction, and the other is that the measurement that you make is always from the beginning point to the ending. We're going to do an example or two with that in just a moment. So here's the point. Direction is always from the starting point to the ending point. So if I were to take a trundle wheel and I were to all over the place, and if I started here and I stopped, my displacement is not the total path length, that's distance. My displacement would be actually a straight line from here to here. My displacement, and this, if this were 1 centimeter, 1 centimeter to the right, and that would be my displacement. For displacement is D with an arrow on top, and we use, it's a vector. We could S with an arrow, we could do X with an arrow. I should have another blank in here, a Y with an arrow as well. So we're going to go to your equation sheet, your unit sheet, and add in displacement. So we're going to go displacement here, and fill in the blanks. So this is going to be meters east, down, anything along those lines, anything that has distance with a direction. There will be an equation to it, and we'll do the equation in a short bit. All right, displacement is because it has direction. There's an equation, as I just mentioned, and I'm going to give you the equation like this. And I need to verify that got that right. Yep. Vectors here as well. All right, so we've got a Greek letter in there, and we'll unpack the letter in just a moment, and we'll actually use this equation. But for now, all I want you to do is just to get the equation down, and just realize that doesn't change. X is your displacement, and this is just your final position. This is your initial position. You'll be able to right now about how to use that. So just for it. Our equations are just shorthand methods of describing our ideas. Okay, we should be able to do that now. The Greek letter delta represents change, and we'll use that quite often this year. When a change is indicated, the direction is always final position, the end position. And that's what we got up here. Final position minus the end position. So this bullet is just a fancy way of saying what that equation means. All right, and this we'll do example number 2 in the next video.